Ever seen those AI fails that make you do a double take?
Oh, definitely.
I read about this autonomous vacuum, kept trying to clean a patterned rug, just bumping it over and over.
Convinced it was dirt, right?
Exactly. Or like a chatbot getting stuck in this loop, just repeating the same nonsense phrase.
Yeah, those aren't just funny glitches, are they? They actually hint at something, well, deeper about how AI learns.
Right. And that's what we want to dive into today, this idea of generalization discrepancy.
Exactly. Think of this deep dive as helping you understand why AI, even with all its power, can have these really surprising blind spots.
Okay.
Our mission here is basically to unpack why AI sometimes fails in ways you wouldn't expect. We'll look at that gap between its training and, the real world's complexity.
And we've got some material to guide us through this.
We do. Some compelling insights from our sources that should help make sense of it all.
Great. So generalization discrepancy sounds key. Our sources mention local generalization and global generalization. Can you break that down?
Sure. So imagine local generalization. That's basically the AI's rulebook. It's built only from the examples it saw during training.
Ah, so just its little world of data.
Precisely.
Yeah.
Its understanding is confined to that specific data set. Now, global generalization, that's everything.
Everything, like the whole real world.
The entire universe of possibilities, every real-world scenario, every example, including tons of stuff the AI probably never saw in training.
Okay, so the generalization discrepancy is that mismatch between the AI's limited learned rules and the much bigger, messier reality out there.
You've got it. And that mismatch leads to what we call a blind spot.
A blind spot, meaning?
Meaning those are the situations, the real examples, that the AI's training just didn't cover. It's like trying to navigate a whole city with a map of just one single neighborhood. You're going to miss things.
It makes total sense. And one of our sources uses that classic example, right? The black swan problem.
Yes. It's a perfect illustration.
How does that fit in?
Okay, picture an AI. It's been shown thousands, maybe millions, of pictures of swans, but every single one.
Every single one is white.
Exactly. So through that local generalization process, the AI develops a very firm rule. Swan equals white.
That becomes its definition, based on all the evidence it has.
Right. From its perspective, its limited world, that's a perfectly logical conclusion.
But then reality throws it a curveball.
Exactly. Because out there, in the global generalization, in the real world, black swans exist.
Which directly conflicts with its rule.
Totally. The AI's learned rule, swan white, simply doesn't account for the broader truth that swans can be white or black. The black swan is completely outside its learned experience.
So its blind spot here is it literally can't see a black swan as a swan. It looks at this black bird and its programming just says, nope, doesn't fit the rule.
Correct. Because its rule is so narrow, defined only by white examples, when it sees a black swan, it makes the wrong call. It concludes, black swan is not a swan.
Wow. Okay. It fails to categorize something that clearly is a swan to us. So it makes a mistake. But does it know it made a mistake? This gets into that error blindness idea, doesn't it?
Absolutely. That's a really critical piece of this, error blindness. The AI often has zero awareness of its own limitations or mistakes.
So in the swan example, it doesn't doubt its swan equals white rule.
Not at all. Why would it? Within its training data, that rule was always right. 100% accurate. There was nothing in its world to suggest otherwise.
So even when it sees a black swan, which, clear proof its rule is wrong, the AI just doesn't flag it as a problem. It doesn't think, hang on, this contradicts my data.
That's precisely it. Unless it gets some external correction, unless someone tells it essentially, hey, black swans are swans too, it'll just keep operating on its flawed understanding.
It's stuck.
Stuck within the boundaries of its initial programming, yeah.
And that leads to what the sources call continuous error. It'll just keep making that same mistake.
Exactly right. Because the underlying blind spot, the gap in its knowledge, it hasn't been fixed. So it'll consistently misclassify every black swan it encounters.
As not a swan. Over and over again.
Over and over. It repeats the error because it has no internal way to self-correct that specific blind spot.
Okay, so how do we fix this? I mean, it seems obvious, right? You need to show it black swans.
That really is the core solution. The only way is to expand the AI's local generalization so it better matches the global reality.
So introduce new data.
Yep. Giving new examples, in this case, lots of pictures of black swans, so it learns the rule needs updating. Swans can be black too.
Which means? AI training isn't a one-and-done thing. You can't just train it once and expect it to handle everything forever.
Absolutely not. Our sources really stress this point. Without continuously expanding its knowledge, an AI's performance, its accuracy, its reliability, it's inevitably going to decline.
As it bumps into more things outside its original training.
Exactly, as it encounters more of these black swan type situations. One source even talks about AI having a kind of limited effective lifespan if it can't adapt and learn new things.
That's a really big takeaway. So if we want AI systems to stay useful and, well, dependable, we need to be actively managing them constantly.
It's essential. You have to proactively look for these blind spots. Find where its learned rules start diverging from what happens in the real world.
Like stress testing its knowledge.
Kinda, yeah. Testing the boundaries.
Mhm.
And then the fix is continuous updates.
Feeding it new data, new examples, letting it refine its understanding, update those generalization rules.
That's the ongoing necessity. Because the real world isn't static, right? It's always changing. New situations, new kinds of black swans can always pop up.
So continuous monitoring, management, updating the training data. It's not just nice to have, it's fundamental.
It's absolutely fundamental,
Yeah.
especially for ensuring AI remains reliable and accurate over the long haul. And this matters directly to you, the listener, because the dependability of AI in so many areas relies on this constant upkeep.
Okay, so boiling it down, the key thing seems to be an AI's view of the world is totally shaped by the data it learns from. And if that data is incomplete or maybe biased or just doesn't cover everything, its grasp of reality will have these gaps, these surprising limitations.
That's a really good way to put it. A succinct summary.
Right.
And, it brings up a really interesting, maybe even provocative question for you to think about.
Wow.
Well, if AI's blind spots come from the data we give it, could our own blind spots, our own biases, things we overlook about reality, be getting baked into these AI systems,
Yeah.
maybe without us even realizing it?
Wow, that's a heavy thought to end on. Okay, so just to quickly recap for everyone listening,
Sure.
we've talked about how AI learns from often limited information. This can create these blind spots when reality differs from its training.
Right, the generalization discrepancy,
And critically, the AI often doesn't even know it's making a mistake, that air blindness.
which makes continuous updates and active management absolutely crucial.
You need to keep expanding its knowledge to keep it effective and reliable.
Exactly. It's just a vital reminder, isn't it? AI isn't magic. It's not all-knowing. Its understanding is built piece by piece from the data we feed it.
So as you encounter AI out there,
Yeah, we really encourage you to think about this learning process. Consider the potential for these unseen limitations, maybe even mirroring our own, to shape the intelligence that's becoming such a big part of our world.